Hi, my name is Jeremy Munn, and I am an intern from the University of Florida pursuing a degree in Natural Resource and Conservation. I'd like to tell you a tale called Adventures in Interning, a tale of surface water monitoring. Here is a little backstory. The Clean Water Act allowed the EPA to govern water pollution by restoring and maintaining water quality by improving point and non-point pollution sources, and delegated this to Florida's Department of Environmental Protection, which issued a National Pollution Discharge Elimination System permit. Wow, that's a mouthful. To Escambia County as a co-permittee with the City of Pensacola, the Town of Century, and the Florida's Department of Transportation in 1999. Escambia County's water quality and land management protects and manages watersheds through the best management practices by monitoring surface water techniques using the FDEP Standard Operating Procedures FS 2100. How do you monitor watersheds? This is where our story begins. It's very important to calibrate the sensors before heading to the field. The dissolved oxygen, DO, is temperature dependent, so it's very important to include that when determining the calibrations. pH is needed to be calibrated to 7 and the specific conductivity at 1000 or higher, depending on the surface water being tested. Because salt water is salty and fresh water is not. And sometimes, parts of the watershed are affected by tidal forces, causing variable salt concentration. It is always very important to know your watershed's hydrology beforehand. Our journey to monitor surface water takes us to our first collection point downstream, and it will continue at different points further upstream as not to sample the same water twice. Psst, it's because creeks flow from upstream to downstream. Once we got to our first sampling area, there are two ways to take a sample: a direct grab and an intermediate vessel technique. Did I mention when you take a sample it's freezing time? Do not believe me? When you take a sample of a watershed, it represents the water quality at that specific time and place. So essentially, you're capturing time at a location. Okay, it's not exactly freezing time, but I like to think so. The direct method is done by placing a clean collection bottle, or bag in this case, at the appropriate level, upright, and the open face upstream to collect oncoming water, leaving some air at the top, removing the bottle or bag, closing the lid, and that's it. Unless, of course, you account for trying not to disturb the settlement on the bottom, taking the sample upstream from your location, and having to get in the water to collect a great sample while all at the same time trying to stay dry. By the way, staying dry is not always possible. This is where the intermediate sample method comes into play. Just make sure you grab a big enough vessel to collect enough water to fill all of your samples. The vessel needs to be cleaned and rinsed ample times, usually 3, with the site water prior to collection, taking extra care to minimize agitation or aeration of samples if volatile organic compounds are collected, and do not touch the lid of the container being filled. No problem, right? Except the task is usually done on a pole. The sample is occurring in moving water systems and usually hard to reach locations. Closing that lid is sometimes an art form. This does not include the samples we gather at a site. Next is turbidity. It is collected, making sure we also rinse with source water ample times before the collection, and placed in a device used to check small particles suspended in the water with a tungsten source lamp. Yep, a tiny little lamp. At this point, it is important to note that we use a chem wipe to clean the outside of the glass container, and we always wear gloves when we collect any sample. It's just good science. Next, a data collecting sensor is then placed into the water at appropriate depth and records continuous real-time data. Remember, we calibrated it for dissolved oxygen, specific conductivity, pH, and temperature, just in case you were wondering what the sensor data was collecting. What's that? The bottles? Oh, that. They were used to collect organisms like E. coli, fecal coliform bacteria, which is indicator of humans' presence harming pathogens, and chlorophyll A, as well as nutrients and metals. The samples need to be stored in ice water and kept in a cold, dark place, it's extremely important to do this. The very last measurement done is using a Secchi disc to check the transparency and the depth of the watershed. It is a very simple yet cool tool and measurement. Place the Secchi disc into the water and lower it until you can no longer see the difference between the black and the white quadrant. Once you are sure, note the marks on the rope and raise it back up. Count the notches and you have your depth for transparency. Next, place the Secchi disc back into the water and lower it until it hits the bottom of the watershed. Again, note the notch, raise it back up, count the notches, and now you have the depth of your watershed. Neat! After all of these samples are taken, we rush further upstream to collect samples, and all over again, repeat the process until all of the watershed sampling points are done. Then we race back to the lab, taking care not to speed, safety first. The collection of all the samples must be returned to the lab within a 6-hour period. Once back, the equipment needs to be put up, the sensors need to be recalibrated to ensure that all of the samples taken in the field were accurately measured. Well, this concludes my journey and my story and the adventures of interning. Man, what a ride it was. Thank you, Water Quality and Land Management, for the opportunity to protect our community and our environment, as well as your patience in answering my questions. You truly made it an enjoyable internship. Thank you.